Hi guys, please stay in the meeting. We'll start the session in a few minutes. Okay, let some more people join. Let's wait 2 more minutes. Wait 2 more minutes. Okay, we'll start at 6:32. Okay, so let's start with the session. Okay, good evening, everyone. I hope you're all doing well. And so basically, today we'll see what exactly is digital twin and what are the different applications and what is the exact application of digital twin in predictive maintenance. So before we begin with our session, I'd like to know from your side, right? What do you get by the word digital twin in your own, in your own words, or you might have heard this somewhere. That's why maybe you joined. Or what intrigued you about this, right? So, what do you think a digital twin means exactly? Anyone, if you want to unmute and say. Anyone would like to say anything about digital twin or why you thought of this as an intriguing subject? Okay, Satvik, I'd appreciate if you have your mics open, and it's okay if you want to speak in Hindi or Marathi or English, whichever language.
Digital twin is the virtual representation of an object, sir.
Yeah,
Like,
that's a great answer, Satvik. So basically, a very simple, summation of what digital twin is. It's a digital representation of an object. So, but what is this digital twin used for? What is this representation for? Right. So we'll look into that and what are the exact representations. Why we exactly need to do this. So let's start with the basic the definition. So as Safik said, so it's a digital representation of an object, but in the industry terms, we call the object an asset. So asset you might have heard. So asset is something you might somebody owns or has the right to use or to work with, right? So that is somebody's asset. So let's say I have this phone. So this is my asset, right? So if I make a virtual representation out of this phone, exact similar copy of it, but it is a virtual model. So that will be called the virtual. Uh, so that will be called the digital twin of the phone, right? So what it does is replicates everything that is about that particular asset, not only how it looks, how the 3D model is, but everything inside it, and how the properties, how it functions, everything, right? So let's take an example. Like I've given a structure here. Like I've given a structure here. So let's say there's like an aeroplane, right? And if you had to create a digital twin for this airplane, what exactly we need? We need lots of sensors and circuitry or electronics that give us lots of feedback from the airplane, how it's working, what are the various operations going on, what is the different equipment that is added on the aeroplane doing at a specific time, right? Is all this thing is already either automatic or in manual input. So all that data will collect with sensors and other things, and will store it in a database. Other thing we need is user input. Even user input, we can see a historical data like the previous flight data of the airplane, the current flight pattern, or other things that require user input. That data also will include here. So we have like a very big huge database, and then we take in the virtual, the 3D model, or in that also there's lots of things we'll discuss about that. Then you combine everything, and then you get the digital twin. So what is a digital twin used for? See, firstly, digital twin can be used in any domain in manufacturing, right from designing a component, designing a product, to how it works, and how can we optimize the systems, to after it is launched and in the hands of the consumer, how can we further update that, or you can take information from that, and do maintenance on that. So in all those fields a digital twin can be used, right? So very versatile, right? So like I've mentioned here, yeah, I've highlighted like prediction of future, defining or optimization of control, right? So that all things can be done with use of a digital twin. So did you all understand what exactly a digital twin is? Guys, I need a response from you.
Yeah, we understood.
Yeah, okay. Okay. So let's see about the applications of this digital twins, right? Because there's lots of information that we're trying to gather in one single place. So in manufacturing, like I've given shop floor performance improvement. So shop floor is basically, you have seen those automated manufacturing lines, right? Or sometimes there are human workers as well. So those manufacturing lines, let's take an example of the vehicle industry, the automotive industry. So in automotive industry, the timeline is very optimized for this, shop floor. So they have like calculations how in just 2 minutes one car is made, like from scratch, from the sheet metal, the engine, the interior parts, just in two minutes from the start of the assembly line to the end, how the car is made in just 2 minutes. So in this way, it's very optimized. They have like a very structure that okay, in one day we have to make thousands or 1,000 cars. Yeah, this is how timely and structured it is. So in that, if we add a digital twin, right, and let's say we same design that same thing in a virtual manner, and then we can test different things, how we can optimize that system more, and how can we, instead of making 1,000 cars, how can we make 1,200 cars in a day, right? So we can optimize that system, right? So that saves lots of time and money for a company. That's why the companies invest in this technology. Then we have self-driving car. So any examples for the self-driving cars that you have heard of currently? Anyone?
Tesla.
Right, exactly. And if you go and research about Tesla, what they do is their cars when they're running on the streets, and even when you're using the self-driving or you're not using the self-driving, mode, they take lots of data like where you're going, what the speed is, how the car is handling, what is the driver input, and they transmit all this data back to the company. If you go and research, this is like very you'll get clear evidence there. So that helps them in designing and improving their self-driving systems because it's not that perfect, but it's really great, and that is how they're improving by taking that data and implementing it in the digital twin, right? And that's how the self-driving autonomous cars get better and better. Then we have design customization and predictive maintenance, which we'll be talking about in this one. I don't want to spoil it just yet. So predictive maintenance we'll be talking about in this one. Then come to healthcare industry. So healthcare industry is also you'll be stunned like the technology advancements that are going on. So currently they're trying to develop or even have developed systems where you can model the whole human body in a 3D format, with all the materials and everything like that, simulation based. And then you can add AI and machine like data science in that, and you can like let's say we take an example of like an heart, right? And there's some blockage in the heart, so we can maybe scan somebody's heart, and then we can in the virtual medium we can test if this medicine will work on him, right? If it works in the simulation, it might work on the patient itself. So there we can improve our medical systems as well. In the supply chain also it's used very widely. So you might have seen those big container ships. So whenever they come to a port, they have like a very specific timeline. In this many hours only, I have to load these many crates, and I have to go forward. If there's an issue somewhere, there's lots of time wasted, right? So that is also where we can use digital twin, and you can optimize those systems, right? And even in not only that one, but in even in like Amazon does this, where their warehouse systems they use a digital twin. So if somebody is new there, it doesn't know where something is should be placed, they make a whole structure of the layout of the warehouse, like where should something be placed in order to for someone to reach it very with less time, things like that affect there. So that there also you can use a digital twin. And in customer relationship modeling, so that is something related to marketing where you can design, it won't be like a 3D model, but there's lots of data involved there, and there's AI and lots of things that come into this domain. So to make a digital twin, you don't only need like just the analytical data, you also need the model and the IoT or AI based platforms in that. So, I'll go back to the graphical one, but before this, let's talk about what is exactly needed to make this digital twins. So first, let's talk about data. What kind of data you need? And so there's four things I've mentioned here. So one is onboard sensor data. So let's even this in this let's take an example of a vehicle, right? So in vehicle, if you know, there's lots of ECUs and other management systems which are connected to a circuit board, and from there you can get lots of data from the engine temperatures to the tire pressures and hydraulic pressures, and lots of other things like accelerometers are also there. So driving and all these things are taken into consideration. Driver feedback, the road conditions, everything is taken into, let's say, a sensor, and we can access that data. We'll have like lots of graphs and numerics and Excel sheets with that. Then we have environment data. Let's say your car, is an electric car, and you're going to supply it to Canada where there's lots of low, very low temperature, and you're also going to supply it to India where there's lots of, high temperature. So how will the car function in different environments, right? Because even if you've seen in India, if we take a bike in Ladakh, so there also we face sometimes if the bike is not that uh, upgrade model or good specification. So lots of times the bike won't start, or you'll have like lots of different problems due to the colder temperature, right? So that used to happen previously, but we have better norms now, so it's rare occurrence now. So in this way, you have to see for each thing you're trying to make a digital twin out of, what kind of environment will you place it in, and what are the different effects that will cause it will cause on the product. Then we have product history. Like let's say we have sold 10,000 cars, and what is the data you have received from that cars? If some car has got burned up or is gone into an accident, what was the exact cause for that accident? Was it the driver side issue? Was it the car itself? So you can better the car next time you make it, or even the next generation you can sort those issues out. Then we have consumer or engineer feedback. Lots of personal feedback is also taken into consideration as data. Then we come to a modeling side, where first you need a CAD model, right? So I think everyone knows what a CAD model is. And in this, what the major specification is it should be low fidelity. So what do we mean by low fidelity? See, if I start to make a CAD model of a whole car which has like 10,000, 20,000 components, you know what will happen to your computer, right? So even in industries, this task is a one mammoth task, and you don't only have to make that model, you have to actually run it in simulation, right? So that is like lots of time is consumed in rendering out those kinds of simulations. So we have to make a complex model but keep it low fidelity, which means there's a low complexity, but you're still getting that level of same output, right? So that's various techniques are required for that kind of modeling, where the model size is not that big, but it's still a very complex and it covers everything. It's not like you said, okay, we don't need this. This can be excluded. It's not like that. Everything is included in the model, right from the material of the seat to the wheels and everything, and the electronics, wiring. All of those things are included in such models. So that's in the case of the car. In different products, different things are mentioned. Then comes something is very important, that is material degradation. That is also included in this models. So let's say you're trying to see what is the lifespan of the car you have designed, right? So that also you can test in a digital twin. So let's say you run that simulation for like 10 years, right? You actually don't run it for 10 years. For the simulation time, it will be like few days or few weeks, right? But in that, you will get the idea of how the materials inside the car will degrade within 10 years. Will it be still functional? What issues will arise after 10 years in the car, right? So that all things you can test with, adding things like material degradation. Then we have FEA modeling. So that also, helps with, lots of environment effects that can occur on a component or car in our case. So that also model we take into consideration. And something which is very important in this modeling is the physics-based simulation. So what I mean by physics-based simulation is uh, all of you must have played racing games, right? You might have played NFS or something like that, right? So in that you must have seen the cars have certain physics. When you crash it into something, it might rebound, or sometimes there's like a deformation in the car, right? So that is something called as physics-based modeling. So previous games had very bad physics-based modeling, where if you crash the car into a wall, it would just go flying. But nowadays, as the games are getting better and better with this physics-based model, the you can really replicate the real life scenarios. If a car crashes like this, what kind of damage will occur, right? And you might have seen videos of this as well on the internet, the FEA crashes and calculations that they do for a vehicle. So we have lots of data. We have the CAD model, very complex CAD model. Lots of things are included, and then we combine all of this in a single place, right? And we apply IoT or AI algorithms to it, so we can predict things or we can optimize things to to make the product better and better. So there we can add, with the help of AI, we can add failure scenarios. We'll have like a very, very good exercise for this. So you will get better with this. So for now, just remember this. So all these points are very important. So we'll add certain failure scenarios, right? What will happen if X and X things happen with the product? What will be the result? How can we make it better? In that case, you can do. And also you can apply something like prediction filters or Kalman filters, which with the help of AI. So you can, something that you have not even tested, like in the real world, you can already predict what will happen like 10 years or 100 years after, right? So that is a very great and beneficial thing for an engineering company that are into making products. Okay? So let's look at some more examples now. So in the first one, you can, are you able to see the graphics, right? The moving graphics, or is it stationary for you?
Yes, yes.
Okay, great. So in the first one, you can see there's like a digital twin of a robotic arm made. So let's say you're trying to design this robotic arm, right? First, you make a model out of this, and then using a physics-based model and certain, you give certain algorithms and controls to the model, and then you can test it out if it's able to, what kind of things can we do with this? Is it able to hold a certain kind of a load with it? Does it fail somewhere? Is the design somewhere wrong? Something does need to change before the design itself. You can test all these things, and then after that you can go into design phase and actually make the prototype and go forward with that. So what happens is, in a company, this is a great benefit because you're saving lots of time and money for the company, where you don't have to actually make lots of different prototypes. Okay, this version did work, and let's make certain changes and then make it again, and then okay, this is not also working. So lots of time and money and efforts get wasted. So in this way, you can save lots of time, money, and effort, right? You might think this is a very complex thing to create, but there's lots of talented people sitting in the industry. For them, this is just a few weeks of work. And just give me a second. Yeah, for them, this is just it's a better way to do things, right? Right. So this is a one application. So in design phase, you can use it. The second one, you can someday try in your own homes. So all of you or some of you might be aware of IoT systems that we can use at home. Anyone knows about these systems? Anyone can name one of the system they know?
Sensors we used for door lock and open.
Right, right, right. Yeah. So all there's this right answer. So there's lots of home security systems or home automation systems. So what one does is, for this the base is in the IoT. But what can you do is, you make a uh, digital twin of your own house. You give all the the physics to that, how, what is the volume of a particular room, and you can put a temperature sensor. So let's say and we go there, do some programming. Let's say the temperature goes about so and so degrees, then the AC will itself turn on, or it will rearrange its temperature, or the fan will faster get faster or get slower, right? So accordingly, the house is getting very automated with all of these features. Or if there's some kind of sensor records some movement in that house, so it can light up a bulb for you. So like this, lots of things you can do. These are very basic examples. So this is something you can do as your final year project as well. Make digital twin of your own house, and you can see what all things there you can apply. Lots of sensors and things, IoT applications you can do here, right? And then we have a metro simulation as well. So here, lots of countries you've seen nowadays, like China, like Japan, that train systems are very efficient, and lots of other countries are trying to replicate it. Even India, to a certain extent, right? We are trying to get our railway systems better. So this also you can optimize if, let's say, in the future, because Now we are trying to see how automated vehicles and trains can work. In the future, let's say we have automated trains. So how are they able to be on time on every station, right? Where should they stop exactly? How much crowd is there, and accordingly, how should we increase the number of the trains? Things like that can be optimized. So structures can be made according to the digital twin. So in that also you can add, let's say you have to design or develop a metro system for Mumbai. So you can test out, like you can make a virtual model of Mumbai according to how much population lives where, and you add certain data of maybe local train or the current existing metros that are there, and you can see how much how much public uses it on a day-to-day basis, and you'll see, you might get like a map where you'll see there are areas that people are not able to get, not near staying near the metro, so they travel or prefer some other kind of transportation. So you can design a metro line that goes through all of those areas that are not connected maybe. So these things you can test out and optimize and structure with a digital twin. Even before planning or making some construction, you can do this. Then this is used in our weather industry also. If you make they make a Earth's digital twin with all the elements, and and our atmosphere. So imagine making an atmosphere in a virtual medium where lots of gases and all the simulations exist, right? So there also you can see after 10 years how will the situation on Earth be, what will be the temperatures, what will be the land spread, or how much the melting will be done on the ice caps. So all these things also you can do on digital twins. You can simulate this data, and this has been already done in the industry. Lots of industries have started doing this. Back, I think 10-15 years, they've started doing this, and this is something that is just coming in India. And digital twin itself is a newer subject, industry 4.0 subject. So it's a very good subject to get into right now. Then we have something called as truck automation system, like delivery systems that some of the companies like Amazon are trying to achieve, right? So automated delivery systems. So in that also they can see how the delivery patterns and how this systems can be optimized. So these are some of the examples that are currently used in the world, that currently use the digital twin, right? So coming back to that was about the digital twin part of the site. So let's come to our main topic, that is digital twin for predictive maintenance. So what do you mean by predictive maintenance? Anyone would like to share? So there's like three words: reactive, preventive, and predictive. What do you think is the difference between this? Let's start with reactive first. Anyone? What do you think reactive maintenance means? Anyone? Karan, Amia, Satvik, what do you think reactive maintenance means? Okay, no issue. So see, reactive maintenance is something we do after something bad has happened. Let's say you have a bike, right? And it gets shut down or something bad happens with the bike. So after that happens, you're trying to now do maintenance and fix it up. So that is reactive maintenance. What is then preventive maintenance? So even before your bike shutdowns or something like that, the company specifies you in every 6 months to maintenance. So that you do previously, right? So that is preventive maintenance. You're trying to prevent any mishap or any issues that might occur in the future. Now, what is exactly predictive maintenance then? So, see, preventive maintenance is something you do before, but you're not always optimizing the time right there. You might, the bike might be fine, and you even still do some kind of preventive maintenance. And there you're wasting a little bit of time. So, in your personal life, that kind of time and money doesn't matter, but in the industry life, this time and money is, in lakhs of crores of rupees. So there, predictive maintenance is needed. Like when, let's say, your bike might go, some issues might occur tomorrow. So today you're doing maintenance. That is something we can call a predictive maintenance. Right? Just before the disaster, you do maintenance a little bit before. Not like you have it planned already and you do it. Right? So that saves lots of time and money for the company. So this is what companies usually try to do. And estimating where and when exactly you need to do the predictive maintenance is the tough part in here. Right? Preventive maintenance you can do anytime, before an issue can come. Reactive maintenance obviously you do after something has occurred. But predict exact moment just before the disaster, if you do maintenance, you will save lots of time and money for the company. So that is what predictive maintenance is, right? So how can we relate a digital twin and use it to do predictive maintenance? So industries that use this technology to do predictive maintenance. So one of that in the center you can see GE. So in GE General Electric, they have lots of power plants. Right? So in this power plants, as you can see in our country as well, you have lots of currently we have lots of power outages, right? So lots of maintenance and things are going on. So they say we have to shut down power and things might go wrong or some kind of maintenance is happening. So what they do in GE, they have a system called as Predix, and this basically takes in all the plants that are that they have currently and that are running in different locations, and they take all the data, as I told you, all the data they take from the different plants. And if one plant is in maybe Canada and one is in Texas, then different simulations are run for both of those plants, right? And in this way, for each plant, they can see, okay, when exactly a certain so and so component in this kind of product needs maintenance or change or things like that. So in that way, they can do a very, they can take just small time, fix some things, and then, start the plant again. So in that way, they optimize it a lot, the system, and you don't face large, power disruptions or power cuts like that. And another example, let's take Microsoft. So they use something called as Azure Digital Twins. So that they're using to, as we looked at the example of the house, a digital twin of a house, they do this for a whole building, right? So all the air conditioning systems, what is the humidity of a particular floor, what is the temperature, how many people are working there currently, and accordingly, the whole building is like a living thing, right? You can assume it like that. So they're doing it for a whole building. They're making simulations, models and simulations, virtual models for a whole building like that in a way. Microsoft is also using it. Then we come to Dassault systems, right? They are also using it as 3D experience, something called as 3D experience. So they use usually for cars and planes, as we had those examples, right? But one of the most impressive things they've been able to do is making a human heart model, and they can see how the heart functions, and if certain things X and X things might go wrong, what are the things that happen with the heart? How can we solve that, right? What kinds of medicine will work on this simulation? So in that way they can test medicines already in the simulation itself, right? So that's a great thing. Imagine in the future, you maybe 10, 20 years later, You go to a doctor, you get scanned, your whole body is like a virtual model of your whole body. And there you can see what things might happen to you after 20 years, what kind of diseases might you contract if you have certain kind of diet, certain kind of lifestyle, right? So all these things you can already, you might have seen certain, uh, tidbits of this technology being used in current technology as well. So you have, you're right, Apple watches and things that are using similar kind of technology to predict what might happen or how your current conditions are. Right? So digital twin, the model is digital twin has a very bright future and is being used in lots and lots of industries currently. And you could, try and come up with a digital twin of your own for your final year project. So something that you can work on. Then let's take a case study about this, all of this. So before the case study, I'd like to ask you if you have any doubts about anything I've taught till now. So we can continue with the case study. Any doubts, anyone?
No, sir.
Okay. So, let's take a case study of a predictive maintenance done to save a bridge. So this man, I won't go to spell his name. It's very difficult, right? So what he did was he was just, going home one day and he saw that there's lots of bridges in his hometown that are not very well maintained and there's lots of cracks and all. So with the help of a company named SAP, they use lots of IoT sensors within the bridge. They made a 3D model of that bridge and what the data they were receiving, like the wind speed, the vibrations from the vehicles that are going on the bridge. All this data, they come, the took the data and applied it on the bridge, simulated it, and they found out various kinds of defects within the bridge. They found out, okay, these bridges need immediate attention. These bridges maybe 5 years they'll be okay with this condition right now they are in. So all this data they get, and they were able to save lots of bridges from collapsing that were like in a very red zone. Right? So in a similar way, can't we do this in India as well? You've seen in India, at least once a year, you see in the headlines some bridge fell off somewhere or some building fell off somewhere. So can't we make a digital twin of a building, simulate it, how many years have happened, what is the material condition currently, what is, the underground activities that are happening, what is the, water concentration there, if the land is stable or not. We can measure all of these things, right? You can take the data, you can make a model, simulate it, and you can find out how much lifespan the building has, or when should be. You can predict when maintenance is needed, which part exactly need maintenance, right? So imagine we do this in India, where according to a survey in 2018, 5,600 bridges were taken into considerations for the survey, and out of 50% of them needed urgent repairs, not only slight maintenance, needed urgent repairs. So that's how bad the condition here is. And if we use some such kind of technology, we'd be able to give exact reports to, if a company does this, and give exact reports to a government company, something like that. They can see, okay, this is something serious, and then they can act on it. Otherwise, sometimes what happens is, if you say, okay, this bridge might fall, they might take, not take you seriously, right? So in this way, we can make things better, right, and move towards a better world. So also there's like a Murphy law, right? Anything that can go wrong will go wrong. So obviously maintenance is a very important factor here, and predictive maintenance is the best thing you can do in terms of maintenance, right? So before we end our session, if you have any doubts, you can go forward with that. Otherwise, we'll start with an exercise. Okay. Any doubts, anyone? Okay, so let's come to the exercise, right? So we have like an electric scooter in front of us. Now, I know it's a Ola, right? So you might recognize it. But let's say we have to make a digital twin out of this. What key considerations will you take to make a digital twin out of this? Let's discuss about it, okay? So about data first, what do you think requires to be extracted in terms of data from the vehicle? Anyone?
Dimensions.
Dimensions may be necessary for the CAD modeling, but in terms of data, first we'll look at data, then we'll go in modeling, then we'll look at AI. Okay. In terms of data, what kind of sensor should we add in to take certain kind of data? What is that?
Stress analysis.
Yes, stress analysis is there, but that will also come in CAD modeling, right? Yeah, one thing you can do is you can add sensors like pressure sensors or some other kind of sensors that measure stress or some kind of other things that lots of Ola scooters have their front wheel broken, that assembly gets broken. So you can attach some kind of sensors that measure the kind of stress that are coming towards the wheel and towards the handle, right? So you can measure that and take that data, right? Great point. What else?
Temperature of battery.
Right, exactly. I was waiting for this point. So temperature of battery, we can take the temperature data. Obviously, they're taking it, but in terms of our digital twin, we just talk about that. So we can take the temperature data and live data. We can take from every current uh, vehicle that is running on the streets currently, right? We can take all that live data. What is the temperature? Let's say if it's in Mumbai, where there's temperature going 40, 45 degrees Celsius. So what is the temperature of the battery if it's in maybe some northern state where it's a little colder right now? So what is the temperature? How it's functioning, right? Anything else? Maybe one last point in. Think. Anyone?
Motor specifications.
Motor data is there, how the motor is working. But one important thing is how the user feedback is there. What is the history of that vehicle, right? If there are any defects, what are the reasons for those defects? What went wrong in the system? We can also take that kind of data and we can set parameters. Okay, this is why it failed. So let's try to solve this out and see in the simulations. Let's try to simulate certain solutions, certain scenarios where this error is occurring, right? And we can try to solve that. Okay. So all this data we take. Now let's come to the modeling. What things do we need to model here? I think you mentioned the key point. One of that was dimensions, right? One of it is obviously making the actual model in a software, CAD software. Right? And then somebody mentioned, I think, FEA, right? So the FEA data also comes in. Right? Then obviously there is material degradation and all those kinds of things. What kinds of material exactly, the seat material is, what is it? What is the tire material? What is the chassis material? What is the motor meter out of how it works? So all that things we have taken into consideration. Okay. Now, what about AI? What do you think should we try and predict for this vehicle in terms of maintenance?
Battery life.
Right, exactly. Great answer. Battery life, how long the battery will sustain, right? We're recording all these temperatures and all, how much the consumer is charging the battery, how much is using the battery, how long is it traveling. So all this data is getting coming to us, and we're using this data to find out exactly how much battery life. Because there were lots of cases as well where the people, they were told they'll get certain kinds of range, but they didn't receive that kind of range. So that also we can see, right? Battery life, we can see what kind of range we get in that vehicle. What else?
Condition of motor if it has defects.
Right. Great. Yeah, condition motor is there. We can do something like condition of tires as well, right? And we can then say, or let's say we measure all of this, and the person gets a notification on his phone or on his, display screen that okay, now you need to change tires, or this many kilometers are left on this tire, then you need to change it, right? So small things like this would definitely make the product better, right? What else can you think about this? What can we, take a data, simulate it, and make it better? Power of battery. Yeah, power of battery is there. Let's say we're getting lots of feedback from the consumer that I wanted this much range, but it's not giving me. I need more range, or I need more spacious seat. So that is also some kind of data only, right? So it's coming from the consumer. Or you can see, as we are talking about the problem, right, where the front wheel assembly breaks, right? So how much load can the bike carry if we make two pillions, one driver and one pillion sit on it? What is the max width, right? That they can set, and it will have an optimized load. There's not lots of loading on the front wheel assembly, right? So that also we can simulate, and we can make things better, maybe change materials, or maybe, I think in this model, it's like just one-sided fork, right? So we can make two forks, front forks, and get more stability to it. So things can be done like this. So I think you all have gotten a good idea of what digital twin is, what are the applications, and how you can use this simple tool to make one product that you have already made, to make it consistently better, optimize it, or something that you haven't even made, or that you're going to make. You can already make it, and you can see what the result will be, right? So I think you've understood all of that. And if still you have any doubts, we can go with that. Otherwise, we'll wind up this session. So I'll send you uh, send you the feedback form. While you're filling the feedback form, if anyone still have any doubts or wants to discuss more about it, ask me any questions. Right? We can talk about that. Okay, lots of people have also mentioned in the chat, right? Yeah, great points, guys. Yeah, somebody mentioned yeah, vibrations as well. That's great. Great points. Yeah. So everyone who's actively responding, thanks for that. And this is how I like to usually do it. It's a two-way communication, and then it feels like a communication between engineers. We can have like tech talks and things like that. Yes. I hope you understood this, and I'll share some uh, references as well with you. So you can write this down, and there's some papers and articles you can check, or videos. There's also videos on YouTube you can check about this. So you can note this down. Currently, the most good sources are MATLAB and Siemens is there. So from there, you can get lots of sources about digital twins. Please make sure to fill up the feedback form, and I'll be here for a few minutes more. If you have any doubts, still have any doubts, right? Okay then. Thanks everyone for coming, and hope you learned something, and hope you can use this in your future endeavors. Right? So let's get back next time with another interesting topic. Okay. Till then, keep learning, keep exploring. Bye.
Thank you, sir.